Hello student, very good morning to all of you. How are you? I hope you all are happy, healthy and fine at home. Do you remember what were we discussing yesterday? I think we were discussing about the synthesis of disaccharide, trisaccharide, polysaccharide. Under this heading, we actually studying the stereoselective synthesis of beta mannose. Stereoselective. Do you know that how do you define the stereoselective? These are the sum of the what we can call it as a stereochemical terms are used: stereoselective, chemoselective, regioselective. These are the term generally in the organic chemistry we are hearing. So that stereoselective, or what we can call it as a regioselective or the chemoselective, these are the three terms generally frequently the chemists are using. So let me tell you little bit about that. Chemoselectivity means what? The which functional group. Chemoselectivity means which functional group is which functional group will react. Chemoselectivity means which functional group will react, and regioselectivity means what? Where it will react, and the stereoselective means how it will react. So these are the some what we can call it a general guideline regarding that. So here specifically stereoselective synthesis of beta mannose means where it will react that particular reagent, how selectively we are getting, because there are mixtures of alpha and beta, generally how exclusively we are getting as a beta mannose in this particular topic. So that is the main concern of this topic. So here in this particular case we have learned so far so many different scheme, and we got the how the beta mannose will be predominantly obtained in some cases very high yield, in some other cases some schemes producing less yield. So how that by changing the reaction condition or the promoter or the catalyst, how one can increase the selectivity or that as well as yield of that particular compound. In that way we have learned this topic. So let us see the remaining part over here, because we are studying as a stereoselective synthesis of beta mannose. So let me give let me revise, let me tell you thus up to I think scheme number 8 we have seen how that structure number 22, that is glycoside chloride, it will be treated with that AgSO 2x and in presence of methyl cyanide, and we are getting as according to as a SN one type of the reaction, means the reaction carried out or that group incoming group which is also occur at axial position, and this axial position chlorine group also when the displacement reaction takes place. But this type of the reaction generally, if you talk about the mechanistic pathway, this kind of the reaction mainly occur via intimate ion pair, and intimate ion pair while studying as a SN1 and SN2 reaction, there we already know this concept. So according to that it get acquired, and then it will be treated with methanol, and the in presence of methyl cyanide, the yield which they had obtained is greater than 90%, and the methoxide group present at anomeric carbon. So with the high yield, so up till now we have seen so far. Now this structure number 24 will be treated with, that is para bromo, that substituent other than paramethoxy substituent in presence CF3CH2 or CF3. These are the electron withdrawing group. When treated there, the improved beta selectivity has been obtained by using a methyl or alpha benzyl sulfonyl group at O2 of the donor. Such groups are non-participating, and by their electron withdrawing capacity they disfavor anomeric oxocarbonium ion and formation, thus favoring direct substitution. And for example, reaction of the methyl derivative structure number 25 with cyclohexanol afford the beta monoxide, that is the structure number 26, in 75% yield with excellent beta selectivity, that is represented in the scheme number 9 over here. So let's see this structure number 25. So let us see here the structure which I am showing over here, this one. Let me draw it properly. So here the chair conformation, generally here oxygen atom, and then this is a chair form where these groups were present at equatorial position, and therefore here you can write O all, that is a protected group. Then here also all are O all, then O all, and at this position the group which is attached O SO3, not SO3, I think SO2CH, CH3 here, CH3 methyl group, and at this position, not at a beta position, there will be OSO2CF3. This is a group which let me show you once again over here, not OSO2CH2CF3. So that is the group which is present at axial position, and what we can call it as a beta side, and this is a structure number is a 25, and this structure number 25 will be treated with the reagent like C6H11OH in presence of DMF. As we know that DMF is a dimethyl ethyl DME, I think DME, and then yield is obtained near about is a 82% yield is obtained, and here the compound which we are going to get is a 26. So draw this structure as it is. Where are the changes takes place that you can observe only over here or here. So other group they are as it is, so you write down all these other groups as it is, and now here the group which is present at this position, it is also as a SO3 CH3 as it is, only at an anomeric carbon atom it is going to change over there, and that the group which is not assigned completely, so OH is going to attack from either which side, whether that reaction takes place according to the intimate ion pair or SN2 type, that we don't know, so that we can they are mentioning here only as a OC6H11, and this will be the structure number 26, and this structure number 26 negate the mixture of the alpha beta is 1:9. So generally 1 is getting an 1:9. If you consider as a 10, consider as a 100, 10% of that alpha and 90% of the beta, means here the selectivity of that particular beta selectivity is improved as compared to as if you observe the scheme number, previous scheme, then as compared to this one is improved, and that's why it is beta selectivity is greater in this case. Now let's see another one, condensation of the benzyl sulfonyl protected donor, that is structure number 27 with the moderately nucleophilic alcohol. Structure number 28 has led to monobias. Structure number 29 in 49% and yield only as a 49% yield, even though it is a very less, in a 1:2 alpha beta ratio. Here also if you consider as 100%, and here 1:2 means suppose as a one is a 20% and second one not, here is a 40% and another one may be as a 60%, 1:2. So like that, which is represented in the scheme number 10. Let me show you that. So this is a scheme number, I think is a scheme number 9, which is represented over here. This is a scheme number 9 which is shown over here. Now let's move on to the next point. Let it be how we can represent that reaction. Let us see the structure number 27, and the structure number 27 will be this one. So here observe this structure carefully. You will find here, this is a, we are generally representing the structure in a chair conformation, because chair conformation is a more stable, and rest of the group which are present at equatorial position, I am showing that one OBN, here also as a OBN. And now at a anomeric carbon atom, here is not OBN, here must be as a SO2BN, and now here at axial position SO2, then CH2CF3, CH2 and CF3. This is a group which is present at axial position, and now this is a structure number 27, and this structure number 27 will be treated with structure number 28, and the structure number 28 will be this one. Here is a methoxyglycoside. So here the structure I am representing over here OR, then here also protected OR, this is a monocyte type, then OR, and here the hydroxyl group is kept as a free because it is going to form as a glycosidic bond, and this process is known as a glycosylation. Now remember, what do you mean by the glycosylation? Glycosylation means what? Where one of the sugar unit containing as a free OH, which so that we will get as a desired product, and when this OH act as an acceptor and this act as an donor here, sulfonate type of the glycoside, it is act as an donor, it act as an acceptor, and therefore the whatever process is happen here, whatever process taking place, that process is known as a glycosylation. And for glycosylation it must have the reaction is what we can call it as a anomeric controlled reaction taking place over there. Means the glycosidic bond formation takes place between this hydroxyl group and this group, and so that we are going to get the product nearly is a 49%. The solvent is used here is a methyl cyanide or methyl nitride, and the yield which they have got is near about is a 49% yield they had got. And now where this here R is a taken as an group is a para bromo this C6H4. So this is R is nothing but as a this type of the group they have considered, they had considered there, and the structure which they have got is a this is a structure number 28. The structure number 27 and 28 coupling takes place together according to as which reaction, according to there the no proper what we can call it as whether it is from above or below. So that is a mixture of the product we are generally obtain here in this particular case. So let me show other groups as it is OSO, SO2, BN. Then here you can write as it is O, all, O, all. Here also as a O, all means that these are the protected group. Now here I am showing this type of the bond, means we cannot assign whether it is alpha or beta. And now then this hydroxy group, oxygen atom over here, and we can show this one. That is the way we can represent here like this. And then other thing we can show as it is this way. Now here we can write as a OR, this one also OR, here also RO, all are group present at equatorial position. And now this OME, this is a glycoside, and therefore does this, if you observe this structure carefully, does this structure shows positive toluene test? No, because there is a no hemiacetal type of the structure. Hemiacetal part is not present here, hemiacetal group is not present over there, therefore there is no question of giving the positive toluene test or the positive fillings. And this is the structure number 29, and the product which they are producing alpha and beta 1:2 ratio of this. This is nothing but as a disaccharide. As we know that disaccharide, once again the two sugar unit combined together through the glycosidic bond, that is known as a disaccharide, and whatever process is this process is known as a glycosylation, where this bond is nothing as a glycosidic bond formation takes place over there. And this is a scheme number 10 over here. This is a scheme number 10 which I have represent over here. So let's see here, and in these studies that Scurage has shown that to achieve optimum beta selectivity, complete formation of the manosyl sulfonate is essential. before addition of the glycone component, a major development in the sulfonate approach was Kriech is another scientist name. Kriech serendipitous observation. Kriech serendipitous is a scientist name. Observation that Kahane activation of the manosyl sulfoxide structure number 30 with TF2O in the presence of DTBMP at -78 degrees centigrade in CH2Cl2 dichloromethane, followed by exposure of the intermediate triflate, that is the structure number 31, to the alcohol 32, led to the disaccharide, that is structure number 33, in an excellent yield and very high beta selectivity, and which is represented in a scheme number 11. Let's see these and just now we have seen this is one of the disaccharide, and mainly the stereoselective we will get as a beta manosides. Let's see another structure over here, how we can get this structure. Let us see, that is the one of the structures. Now let us see the another structure I am representing over here. See carefully. Then here is this is a chair conformation, because it is a most stable chair conformation, and that's why we are representing that one. And now at this carbon number 2O BN, which is present at the axial position, because we are talking about the manosides, and rest of the thing here we can show here. This one generally now this is protected with this one. This is another chair form, and now is a pH benzylic protection is carried out or represented over here, and now here is a BN, and at this position, at axial position, there will be a sulfoxide, this type of the compound, and then there is a pH, that is a sulfonate act as an donor in this particular case, and this will be treated with this is a structure number is a 30. This is a structure number 30 over here, and this structure number when treated with the TF2, that TF2 where DTBMP BMP, that is a reagent used here, and the solvent used as a CH2Cl2, and this is treated near about 28 degrees centigrade, that is the temperature kept, and they have got the structure over here is this one. This is a structure which they have got. This group get replaced by another via intimate ion pair, so that they have got the compound here. This one, let us see. Here is as it is you can write OBN, and then this group also you can represent like this. So here, and there is a pH we can represent over here, and now here will be OBN, and this group also present at equatorial position. Now look at our focus is our main point of focus, this group get replaced by this adding with that reagent, so that we are going to get here OSO2 CF3. so that is the group which is got over here. And now this is a structure number 31, and now this structure number 31 further treated with this structure. Let me show that structure once again over here. This is a structure where at axial position there will be this is a glycoside actually, OMe. Then at this at 2 position, this is a what we can call it as a protected acetyl group, this one OAC. Then here also OAC, here also OAC, but here this is a glycoside, and for desired product we kept hydroxyl group over here is a free. And now by attacking here, this reaction can take place according to as a SN2 type of the reaction preferably, and this the two compound when temperature kept as a minus 78 degrees centigrade, very low temperature, then 0 degrees centigrade. What is going to happen here? Now this is act as an donor, this will be act as an acceptor over here. This is a glycoside, and this is a phosphate type of the glycoside, and so reaction takes place together. This process is once again is known as a glycosylation, because there is a formation of the glycosidic linkage or the glycosidic bond formation takes place, and the resulting compound will be obtained, which is known as a disaccharide. Remember here, and the percentage of that let me represent this structure here once. Over here, this one we can write as it is. The part of this you can write as it is OBN. Here this is a group. Here we can represent this pH as it is. Here shows it is OBN, and at this position now this bond is going to attack over there. This is SN2 type of the reaction. As we know that it is a concerted and nucleophile approaches from the back side, and we are going to get the product over here is a O. Then this you can show as it is. Then there will be this type of the structure you can show. You can represent other part remains as it is over here, OMe. Then here you can show OAC, and here once again acetyl group. All these groups are present at equatorial position, and this is the compound is what we can call it as a disaccharide. Once again you got as a over here is a disaccharide. This is a structure number 33, is a structure number 30, this is a 31, and this will be 32, and combination of the structure number 31 and 32, the resulting compound obtained will be the 33, and that is nothing but as a disaccharide, because our particular aim here the synthesis of disaccharide. So in this way, and disaccharide with respect to as a selectivity stereoselective synthesis of the beta monocyte. So we got over here, and that the percentage of this we are generally getting beta alpha mixture is greater than 25%. So this, and generally in the what we can call it as a in a carbohydrate chemistry, commonly protecting group in a carbohydrates chemistry are protecting group, introduction, and the remol. These are the some of the basic thing you should remember while studying this carbohydrate chemistry. And as we know that carbohydrates are the polyhydroxyaldehyde are the ketone, and then a protecting group such as C6H5CH2O, and it is introduced under sodium hydroxide act as an base, and the benzyl bromide is used as an reagent, and this is the what we can call it as a blocking of or protecting of that functional group. Generally hydroxyl groups is present, and therefore benzyl bromide used in sodium hydroxide mainly, and whenever it is once we get the desired product, there is a need to remove that protecting group. So how do we deprotect, or how do we remove that group in a mild condition? So generally the molecular hydrogen in presence of the palladium charcoal, it get removed very easily. Second one more is a acetate group, which is generally acetate group. Again it is a commonly used protecting group in a carbohydrate, generally carbohydrate containing as a polyhydroxy. So that hydroxy group can be protected by using the acetic anhydride in presence of pyridine. Here the pyridine plays the role of solvent to abstract the hydrogen atom attached to that oxygen, and therefore the nucleophilicity of that oxygen atom is increased, and it is attacking on that acetyl group. Acetylation, the rate of acetylation is increased over here, and that's why we getting that one. So these are the some of the commonly protecting group in carbohydrate chemistry. I hope you may understand this point. I think with this, let us stop today here. Remaining point under this heading, synthesis of disaccharide, trisaccharide, polysaccharide, we will continue in the next lecture. Till then, have a nice day. Thank you.